Saxon Algebra 2, Lesson 27, Rational Expressions. Ooh, doesn't that sound fancy and hard? It does, and I don't like it. Because here's the thing. The word ratio just means fraction. Okay? Ratios can be expressed in other ways, but it's also possible to write them as a fraction. So we can say the ratio of 3 to 4, but we can write it like that. All right, this is going to come in handy someday because I know there are some word problems at the upper levels where where they will say in the words the ratio of two numbers is 3 to 4, and you have to get to this. So just remember that when you hear something's a ratio, it's just a fraction. There's nothing magical about that. So a rational expression means that there are fractions with letters in them. That's all that it means. And there's no equal signs, right? Because an expression means no equal sign. All right? So it's fractions with letters, no equal sign. We're going to practice working on them. We're going to do a lot of these in the future in lots of complicated ways. So let's practice. 4 over x plus 6 over x plus a. Okay, so we are adding, and we have fractions, and there's no equal sign, all right? That's very important to take note of, because if there is an equal sign, then we can do things differently. But in this case, we know that we have to match our denominators, or as I sometimes think of it, we have to match their booties. Okay? And the way that we do that is only by multiplying. Oh, let me stress that to you. Wouldn't it be nice if we could add a, so it was x plus a, x plus a. We can't do that because we can't add to our denominators. We can only match the booties by multiplying. So in this case, our least common multiple has to be x times the quantity x plus a. We cannot add to make these match. We can only multiply, and so we have to multiply just them by each other, right? So the way that, and we don't have an equal sign, so that means we have to do top and bottom multiplication. And I'll show you that in just a second. Okay, so what that means is, we know this is our LCM. That means we multiply top and bottom by missing pieces. So this, I'll do x plus a times x plus a. And over here, I've already got the x plus a, so I'll multiply this times x. And I'll put parentheses around that just because it helps my brain see it better. You don't have to use a different color, but doesn't it make it really pop when you do so that you can see what you're doing? Okay, so we're gonna have matching booties once we're done with this, but we were only able to multiply. That's how we find the LCM, and we can't multiply each term and try to make the booties disappear. There's no equal sign, so that means we have to multiply top and bottom. All right, so now we're gonna get 4 times the quantity x plus a, that's this, plus 6x, and that's all gonna be over x times the quantity x plus a. All right, so far so good. Now what we can do, what John usually does, and I'm pretty okay with, is distribute in the top but not the bottom. All right, so that would be our next step, is to say let's distribute this. All right, so we would do 4x plus 4a plus 6x. The denominator's not going to change, and before I write it again, I'm just going to add the like terms. So we would have 10x plus 4a all over, the bottom is undistributed, x times the quantity x plus a. Final answer. And that's right. 10x plus 4a all over x times the quantity x plus a. Okay? The sneakiest, hardest part of this is remembering that you have to multiply when you're matching those booties. And so all we can do with a mess like this is multiply them times each other. Okay, let's do another one. I mean, story of my life, right? I always think that's the solution for everything, you guys. Let's just do another one. Example 27.2. Ready? We're going to do 3 of these in all. And that's the end. There's only one topic this lesson, so John's being kind. Add x plus 2 over x plus 4 plus 6. Ooh, a floaty 6. You know how I feel. Not good. Okay, we're putting him over a 1 right away. All right, there's no equal sign. We can't make the denominators go away. All we can do is adjust top and bottom to make everything match. Matching booties can only be achieved through multiplication. We cannot add. So there's no way to make this x4 and this x squared mush into a single thing. We can only multiply them. So our least common multiple is going to be quantity x plus 4 times x squared, right? And you could write the x squared at the front if you preferred. This guy gives us no trouble at all, right? We're going to have to clean him. We're going to have to fix him up, but he'll go along with anything. He doesn't care. All right, so now we're going to multiply top and bottom missing pieces. So I compare each denominator to this and multiply by what I need. X squared, top and bottom. I'm going to give him parentheses because it makes me nervous not to. This is just a 1, so this needs everything, right? X plus 4 quantity times x squared. X plus 4 quantity times x squared. I'm going to leave that weird with the x squared at the end just for fun, to show you that it doesn't matter. And when I multiply by this quantity, I definitely want the parentheses, all right? So now everybody's fixed up. Everybody should be in good shape. Now let's go through, oh, look right here. I need to have parentheses on that too, don't I? So this is gonna distribute like this. And, oh, this is gonna be weird because I've got a 6 and I've got an x squared. So both of those need to come together and distribute like that and like that. And then the 2. Okay, I'll walk you through this term. It's confusing. All right, let's distribute here. We'll have x cubed plus 2x squared. Okay, so now we have 2 pieces on the outside. So what I'm doing, you don't have to rewrite this, but I am rewriting this as 6x squared times the quantity x plus 4. Do you see how I did that? The 6 and the x squared go together on the outside, and then the quantity stays the same. So now I can do that, and it's a lot more, it's clearer in my head. These two were spread apart before, and it was a little confusing. But now I'll multiply. That will be 6x cubed plus 24x squared. I'm running out of space. I'll just make it in the next line, and then we'll clean it up on the next path. Okay. And then I've got, this is a plus there. It got kind of buried in my other guys. So it's plus 2x plus 8. Okay, so that's just my numerator. I'm not doing the denominator yet. I'm going to clean this up, and then I'll add the denominator back in. But the denominators are all perfect and fine now. All right, finding like terms. There's a pair of cubes, and there's a pair of squares, and then a single x and an 8. All right, so I just combine these. So I'll have 7x cubed plus these two, 26x squared plus the 2x plus the 8. That is my final pretty numerator, and now the denominator will just be my LCM, because that's what all of these got turned into. And I'm going to write it with the x squared at front, because that just feels more organized to me. And again, we distribute in the top, but not in the bottom. That's just kind of mathematician's preference. Beautiful. If you ever distribute something and John doesn't, just check and make sure that your answers are the same. But if let's say you distribute and John doesn't, just take his number that's undistributed, distribute it, and see if it matches to yours. All right? So it's not the end of the world. Distributing is neither right nor wrong. It's just a question of what form you want your answer in. Isn't that exciting to know? One more. Sometimes I say things and I'm like, oh my gosh, I'm so interested in that. I think that's so cool. And I'm like, my poor students, I don't think they care. But that's okay. I know you do. All right, ready? One more. Oh, John is so tricky in this one. Remember, these things that I'm showing you, they're rational expressions. They're fractions, so we can call them ratios. And they have letters in them, so we call them, instead of calling them fractions, we call them rational expressions. This goes out. Minus 1 over. Okay. So what do we notice? There's no equal sign. That tells us we cannot make our fractions go away. Remember, if there's an equal sign, we can make our fractions totally disappear. But there's no equal sign, so we're stuck with them. That means the best we can do is multiply top and bottom so that the bottoms match, and we can squish them together. Matching booties is our goal then, right? We want to make these two match. But we remember we can only do it by multiplying. We can't add to anything or subtract. Okay, good to know. But when we look at this, we go, holy mackerel, that's a hot mess. This looks nothing like that. Do we multiply this whole thing by that? Possibly, but here's a better idea. What if we try factoring this first down into binomials and seeing if by any chance we have overlap, right? So we go like this. We'll pray that John's will allow us to factor this by inspection, right? Hopefully we don't have to drag out the man-eating dragon or complete the square on this monkey. Let's just see if we can do it by looking at it. So we would want two numbers that multiply to 3 and add to 4, and hallelujah, there they are, right? Ah, thank goodness. Now we can just squiggle that out. Don't erase it. Please, don't erase. Don't ever erase on a math problem, you guys. Just draw a line through it and move on. That is this. Now we see, okay, now when we go to combine these two to find our LCM, which I'm going to write up here so I have a little more room, we've got some overlap. So comparing these two, I can see, well, we're going to need an x, a plain x, and we're going to need an x plus 1. They both have that, and then we're going to need the x plus 3. Right? This is a collection of all the different factors that we're finding in our denominators. Our booties, now we can make a match. Now we're going to multiply top and bottom by whatever we need to make the denominators equal to the LCM. This first one has that, and it's got that, so we just have to multiply it by x over x. All right? This one has got 2 pieces, but we have to multiply it by the third, don't we? Beautiful. So we've now adjusted both denominators so that they match each other and they're equal to the LCM. EA. That's great. We don't have to worry about those anymore. We're going to turn our attention to the numerators. I can see, look, I need parentheses there because I'm going to have to distribute. And I'm going to circle that minus sign because that's the only part that's going to make this tricky. Multiplying by 1 is pretty darn easy, but we have to pay attention to that minus sign because we have to distribute that sign as well. We haven't talked about that up till now because we've been dealing with plus signs in between, and distributing a plus sign means everything stays the same. But distributing a minus sign means we're going to have to be careful over here. All right, let's go back to this side and start. We're going to have x squared plus 2x, right? That's pretty easy. Minus 1 times x makes minus x, and minus 1 times 3 makes minus 3. Make sense? Okay, cool. My denominator is fine. I'm not going to worry about that. I'm going to go ahead and combine like terms before I rewrite that. It'll be x squared plus x, right? Because this is a minus 1x. Sometimes it helps to do that. 2x minus 1x equals 1x. Minus 3, that's my numerator. And then the denominator is x times quantity x plus 3 times quantity x plus 1. Remember, the order that we write them in doesn't matter because order doesn't matter in multiplication. So however your brain wants to do that. That's our final answer. Let me just triple check. I would feel really bad if I got it wrong and I didn't catch it. Okay, beautiful. You guys know Ella Cochran. I've been meeting in person with her, and it's so nice to have a student to like catch when I drop a minus sign or something like that. I'm really paranoid that I'm gonna do that in a video and not catch myself, and then you guys are gonna go crazy knowing that I made a mistake and that there's no way to stop me. It's just sad. So that is one of the things about doing this by myself is I don't have anybody double checking. Okay, but that's right. That's the right answer. Yay. Rational expressions we are going to spend a fair amount of time working on. They will be a part of your life. So just remember, a rational expression just means fractions with letters, right? And we simplify. Okay, 27 is done. Lesson 3 cubed is over. Goodbye.